All right, so here we're going to do our router BGP configuration. Our ASN is 44883. Okay. Here, our BGP router ID is going to be our loopback address, which is going to be 10.10.2.2. All right, so we're going to configure router BGP here. BGP is going to be 44883. Our router ID is BGP router ID, be 10.10.2.2. Address family IPv4 unicast, and we're not going to do anything else in there. We're just activating the address family, and we're going to do our neighbor. Now our neighbor is going to be our next hop address, so this is going to be our provider's address. Neighbor 66. It's going to be 1.2.1, and within here we're going to say remote AS, and our AS is going to be 886. And we have a problem because I don't have a route policy configured. So we're going to have to configure a route policy. Policy allow -all in. Oh, I'm on the address family. I'm going to enable the address family itself. I forgot. There we go. And then here, route policy. Policy allow all in. And then we're going to do a route policy allow all out. So these route policies are just like your route maps on iOS. So this is where you would do some sort of route filtering and tagging and manipulation. The problem here is that with iOS XR, by default, they deny any sharing of routes is the best word. They by default, they deny any sharing of routes. So here what we have to do is say we have to allow just anything that we want to share. And that's what we're going to do. We're going to create this allow all policy that says, hey, go ahead and send all the routes that we want to share. Anything that's in our table, our BGP table, go ahead and share. So here we're just calling that. And then what we're going to do, we're going to create the route policy for that, because it's not going to work if I don't. So route policy is to be allow all. And literally, we're just going to say pass. We're going to hit commit and make sure this works. Oh, I got to X out first. Now, I'm going to give us an error because the order operation sometimes we'll see what happens. Sometimes there's errors. Oh, there's no errors. Okay, so let's take a look. All right, so we have our router BGP configuration. We have our router ID. We've activated the address family IPv4 unicast. We have our neighbor configuration 661.2.1. Remote AS is 886. Address family is IPv4 unicast, and we're doing allow all on our route policies. Let's just double check that our route policy is there. And it is there. So that looks good to go. All right. So let's go to our iNet and configure our iNet. But this guy's going to be running BGP. I'll just check his IP addresses real quick, make sure I configured them correctly. And it looks like I did. So we're going to do a router, BGP 886. We're going to do BGP router ID for giggles, 8888. All right. And then here, we're going to do a neighbor statement, 661.2.2. Remote AS is going to be 44883. And then when we're doing iOS, I actually like to remove the default IPv4 address family. I'm not a big fan of having it, so I usually will remove it. It actually just came up, the neighborship just came right on up, but I usually like to disable it. For now, we'll leave it. We need to do some network statements here, so we're going to do our 8.8.8.8, and this has a mask of 255.255.255. We're going to do our network statement 661.2.0, mask of 0. And let's just take a look at this. We'll save it real quick. Our neighborship already came online. All right, so that looks good. And actually, I don't want to advertise that network. No network mask. We're going to go ahead and inject a default route in our BGP configuration here, so that we can advertise a default route down. We don't want to advertise the 8.8.8.8. We want to simulate that we're receiving a default route and we're going to be able to access internet resources no matter if we know those routes or not. In this case, we are going to do default information originate with a static route redistribution. So here we're going to go in BGP, router BGP 886, and we're going to just do default information originate, and then we're going to do redistribute static. And then to get this to work, we actually need a static route to the default static route. And to do this, we're actually going to do a quad 0 route here, or oddball route. There's a lot of different terms for it. We're going to point it to no 0. And right there, those 3 commands are going to get us that default route. So let's validate that real quick with a show IP route. We'll see that we have it in our routing table, and there it is. And then now we have our default being advertised outbound. So let's check our core router, make sure we're receiving it. And there she blows. We have it in BGP. That is a good thing. All right, but here's the thing. If we keep going further, we're not going to have it in our production router. We have to inject that route somehow into our IGP. Now we can do that in 2 ways. Just double check that we don't have it in our production router, and we do not. So we can do this in 2 ways. We can redistribute the default route from BGP into Ospf. We can do that. But then we would also need to redistribute the other way anyway. Or we could do a default information originate in BGP or in Ospf to inject that default route. So we're going to go into Ospf here, 10, and this one is our area 0. Sorry, not area 0, that's area O. And in here we're going to do a redistribute address family. It's actually the address family, I think. There we go. Redistribute. No, not redistribute. Default information originate. We're going to hit commit here. And an easy way to test this, right? So we just configured it. Ospf database. And if you look at our type 5, you'll see that we have a default route ping in our database. So that's an easy way to check it on this device, is to check our routing, our Ospf database, to check to say, hey, where's that default route? Are we actually injecting or sending that default route out? And in this case, we are. Now, if we go over to our production router, we should see that default route. And we do. It's an E2, external type 2. So that is good to go. We're getting that default route down. Now the problem right now is that our core router, our POP router, our point of presence device, is not running any type of network address translation, so no NAT. So we actually are going to have to send our routes that are in our IGP table to the internet for now. In a normal environment, we would do a NAT, some sort of NATing device, dynamic NAT, static NATs, and we wouldn't send our RFC 1918 addressing space or our server networks that are internal to the internet. In this case, we're just going to make this simple. We're just going to redistribute from Ospf into BGP on the core router. So let's quickly just add that for some quick routes. So router BGP 44883. And here we are going to go into address family before unicast, redistribute Ospf 10. And we're going to hit commit. Remember, we have to do that commit. It doesn't actually take changes. So now if we wanted to go show IP BGP real quick, we have a whole bunch more routes in our BGP table because we redistributed from Ospf. So all of our IGP routes are now injected into BGP, and we're allowing all of those routes to get passed to our neighbor. So if we go into our internet router real quick, we would see that all those routes are now over here. Maybe not exactly preferred, right? We would probably want some sort of NATing device, but you can see that all our routes are here. So now, just for giggles, from production switch 1 here, we're going to go ahead and ping our internet access, our internet service, if you will. And that's because it's just going to be our 8.8.8.8 address. We're going to source that from our loopback 0 just to make sure that works. And it works. So we have end-to-end connectivity from our production switch to the internet. One last step that we have to do here, we actually have to go ahead and set up our IPs, our static IPs, and our default gateways and host names on our servers. Again, we're not going to actually run any applications here. We're just going to test connectivity and verify we can access these servers. So here's this is our shared server. So we're just going to go to sudo host, not sud, sudo host name. We're going to do shared server. And then for our IP addresses here, again, we're going to use the full ID. So this one's going to be 150, 150, 150, 150. And it's a /24, and the default gateway is .1, which you've already configured. So here we're going to do a sudo if config, and we're doing eth0. We're going to do our IP address here, 150.150.150.150. Our net mask is 255.255.255.0. Enter. And we're going to also do our default route. So sudo route add default. It's going to be gateway, GW for gateway. And this is going to be 150.150. Oops, I threw a space. 150.150.1 eth0. All right, so now on this guy, I should be able to ping. I did everything right. The internet, and I can. That is a good test. Let's do the same thing on our production server, and then we are in production mode. So now if we ping here, we should be able to ping it, and we can. Let's see if we can ping our other server and our other subnet. And we can. All right, so we've got good connectivity through and through, and this is our production network right here. This is all this is. We just built out our production network. We're getting internet routes, which is just a default route. And then normally, again, we'd be doing some sort of dynamic NAT and static NATs. In this case, we are just redistributing our IGPs into BGP for the time being. And we can clean that up. We can add NAT later on, all right? All right, that's going to be it for this video.